All right, hello everyone. So we have a algebra problem today involving rates. So it's a word problem, and we have a painter takes 2 hours to paint a room. The painter's apprentice takes 3 hours to do the same job. They work together. How long does it take to paint the room? Okay. So the solution to this problem is taking into account the fact that we have the distance equals rate times time. Often, this equation is used when you're solving some type of distance or time it takes to cover distance, but it applies here. Now, let me concentrate on the part with the rate here, and we have two rates that we're going to work with that involve the 2 and 3 hours respectively. Now, how do I get a rate out of that? Well, a couple ways to look at it. Let me call the rate of the painter, call it RP. And think about it this way. One job takes 2 hours. Okay, that's one way to think about it. The other way to look at it is that in 1 hour's time, 1/2 of the job has been done. Okay, so one job is 2 hours, or half the job has been done per 1 hour. Okay. And likewise for the apprentice, it's very similar. It's just 1/3, okay, because it takes the apprentice 3 hours to do the job of painting the room by themselves. So that's how we can form a rate from that time. That one particular job takes a certain amount of time, or the amount of the amount of the work done per hour is given by the fraction 1/2 or 1/3. Okay, now I'm going to make up some equations using that distance is rate times time equation. So for the painter, the amount of the job done by the painter, we'll call it J sub P here. I'd say it's this. Well, whatever the number, the time it takes to do the job, 1/2 times the time tells you how much of the job has been done. So yeah, if you think about it as 1/2 job per hour times the total number of hours, that is the amount of the job that's been done. Okay, so so if the painter has been working for, like, say 45 minutes, then 1/2 times that time, 45 minutes, you have to convert it to hours. We're just talking about hours here. That would tell you how much of the job has been done. So the same thing for the job done by the apprentice. That'd be 1/3 T, because it's 1/3 of a job per hour. Sorry, that's a really bad 1/3 that I had up there. That 1/3 of the job per hour times the total amount of time tells you how much of the job that apprentice has done. So if that apprentice has worked for 2 hours, let's say, then 1/3 times 2, 2/3 of the job has been done. Okay. But since they're working together, I'm going to add these rates together because, they're working together. And I'm going to set all of this equal to 1. Okay. So 1/2 T plus 1/3 T equals 1. Okay. So that is what describes the situation in terms of knowing the amount of time it takes working together. So 1/2 T describes the amount of the job done by the painter. 1/3 T describes how much work has been done by the apprentice. And we set it equal to 1 because you have one whole job to do, which is painting that room. So if we go ahead and solve this equation, 1/2 T plus 1/3 T equals 1. I'll let you work on the algebra here, but we're going to get a common denominator, and on the left-hand side, we get 5/6 T equal to 1. And then if you got T by itself, it's 6/5, or 1 1/5 hours, okay, because that's what our time was in. and 1/5 of a hour is like 12 minutes. So it's an hour and 12 minutes total. So basically, to recap here, when you're doing these types of problems with you're given two rates and people are working together, or machines, whatever. If you take the rates, which you can form by taking the job done, which is like in an hour, by the total time it takes them to do that job too, and then one, because one whole, and you multiply it by the total amount of time they're going to be working. Well, those added up always have to equal 1, okay? Because you have one whole job to do. So if they're working together, you add the rates times the time. So 1/2 t plus 1/3 t. Again, rate times time for both, or whatever number of people are working, and you set it equal to 1 because it's one whole job, and then you solve. So there you go. All right, well, thank you for your time. I hope this helps.